Good afternoon, everyone. We are going to start working with the law of cosines today. And let me get my screen where we are ready to go. And this is large enough to where you can see it. So the law of cosines allows us to work with a couple of different situations. With the law of cosines, we're dealing with the situation where we have side, side, side. Okay, that's the first example that we're going to work with. Or we could have side, angle, side. All right. And here are the rules. And the reason why they're in two different forms is because we might be looking for a side. If we're looking for a side, then we're going to use this form. If we're looking for an angle, we're going to use this form. All right. So let's get to our first example here. Solve the triangle with the given information. So we're given we're actually given three sides here. This is side, side, side. All right. So we draw a quick little sketch of our triangle. Um, 8, 14, and 19. And because of what we were told, all right, A is 8, so that makes this angle A. B is 19, that makes this angle B. And C is 14. Okay. So based on this, what we want to do first is let's work with the side opposite, okay? The longest side first. By the way, I want to fix this now. I think this was supposed to be side C, just so my notes are matched up, and this was supposed to be side B. All right. So let's call this side B and this side C. I just want my notes to match up. So let's work with the angle that is opposite this longest side first. So from the law of cosines, okay, that I just showed you, we're going to work with this right here, the cosine of C. The cosine of C is that ugly formula, a squared plus b squared minus c squared all over 2ab. All right, there's the law of cosines formula. And we just plug in our numbers. We have side, side, side. So I've got all of these pieces of information. So I'm going to have 8 squared plus 14 squared minus 19 squared all over 2 times 8 times 14. Now I'm going to save ourselves some time here. This turns into the decimal negative 0.451. It's a negative number. And what we have is the cosine of C is equal to that. All right. So since it's negative, okay, since it's negative, must be an obtuse angle. All right. Must be an obtuse angle. And the reason we know that is because of all scholars take calculus. Cosine is negative over here in the second quadrant. All right. So when I do second cosine with my calculator, I find out that C is equal to approximately 117 degrees. All right. Now, when we think about triangles and obtuse angles, a triangle can only have one obtuse angle. There can only be one obtuse angle in a triangle. So that means we don't need to do any subtraction here. We don't need to find another triangle. We just need to find the other information. So now we use the law of sines. to finish. All right. I have that 19 is to the sine of 117 degrees as 8 is to the sine of A. All right. Remember, right now, I only have one angle. Okay. That's all I've got. So I've got to use the law of sines to find us another angle. And when I do this, when I do my cross multiplying and my calculations on the calculator, I find out that the sine of A equals 0.375 and A is 22 degrees. All right. So B is just going to be found by doing 180 minus the 117 minus the 22. So side B or angle B is 41 degrees. Okay. Now I want you to remember what I told you about the fact that a triangle can only have one obtuse angle. All right. This tells me that there's only one possibility. All right. Let's go to our next example. So here we're given an angle between two sides. $25-degree angle between 9 and 12. All right, we are not given side A. We don't know side A. We're told that this is side C, so this must be angle C. This must be angle B. All right, and this is angle A. So now I have side angle side, and we could find side A using the law of cosines, that all those formulas that I showed you. We're going to use this first one right here. A squared equals B squared, all that mess. A squared equals B squared plus C squared minus 2BC times the cosine of A. All right. And we just plug in our numbers. A squared equals 9 squared, which is 81, plus 12 squared, which is 144, minus 2 times 9 times 12 times the cosine of 25 degrees. A lot of numbers, okay, but it's really just plugging into the formula. So when I do my calculations here, I get that A squared equals 29.23. I have to take the square root of both sides. So A equals 5.41. All right. Now, what we need to do now is consider some possibilities. Now I can do the law of sines again. I can do 5.41 is to the sine of 25. Okay, because now I know that side A, remember we just found out side A is 5.41, so now I can do the law of sines, equals side B, which was 9, to the sine of B. And when I do my calculator work, cross multiply, divide, and so on, I get that the sine of B equals 0.703. All right. Now, if you remember when we talked about the law of sines, there are two angles that make this true. Two angles that make this true. All right. The good news is we don't have to do all the work that we did on the law of sines. By the way, I could come up, just like I did on the law of sines, I could calculate my H value. All right. I could calculate H. I'll tell you what it is. H winds up being approximately 4. And look at this. 4 is less than the side opposite the given angle, which is less than 9, which means maybe there could be two triangles to consider, but we're going to find out. We don't have to do all that work again. Let's move forward here. If I find out that angle B is 44.7 degrees, Okay, I just did second sine in the calculator, 44.7 degrees, all right? And remember, we now have two angles. I've got 25 and I've got 44.7. If I do 180 minus that 45-degree angle minus 25, I get 110 degrees. All right. And if we think, well, there could be another possibility, like we did with the law of sines. What if I did 180 minus that 45 to get the other possibility? That would be 135 degrees. All right. So if I did 180 minus 135 minus 25, I get 20 degrees. And this is where it becomes easier than the law of sines. Look at these two angles. Okay, these are the two possibilities for angle C. Now look at our picture.